Hello, everybody, and welcome to lesson 3.1, which is in your textbook on page 121. And I would like you to underline the title, which is talking about congruent figures. And congruent means they're the same size. Trying to get this started right. Hang on. Okay, congruent, same size. So it preserves angles. So all the angles are the same. And also all the side length. And what we're learning today is how to recognize congruent figures and their corresponding parts. The word corresponding means they're in the same location on the picture. On the drawing, let's say that. And here I'm going to put some symbols that you might need to know. This is a symbol for triangle. This symbol means angle. Notice the bar down here is horizontal. It's not like this. So I'm going to show you what it's not look like. Okay, this means something else, less than. So angle symbol, and then we have sometimes a lowercase m that means measure of an angle. Congruent is an equal sign with a little tilde. And a congruent means same measure. It's the same like an equal. But in geometry, it's congruent because we are measuring things. So it's a little different. Congruent. Then we're talking a lot about angles. So an angle is equal if you have that, that bow inside. So the bow tells you that these two angles are equal. I'll just use congruent here. Okay, and then if you have side lengths, it's a little dash. So that means these two are equal. So dash, I'll call it dash, means sides are equal. Okay, bows and dashes. So let's look at this page, this picture here. Congruent figures have the same size and shape. When two figures are congruent, you can flip, slide, or turn to make them on top of each other. Slide, flip, or turn to see that one fits exactly on the other one as shown below. In this lesson, you will learn how to determine or decide if geometric figures are indeed congruent. So this is a slide, you're moving it up and over. This is a flip, you need like a line in the middle. That's called the line of symmetry, and you can flip it over and then you can turn it. This looks like a 90-degree turn clockwise. So a quarter turn clockwise. And so you can determine or decide whether two figures are congruent or the same size by comparing their corresponding parts, which means you want to look at the parts that are in the same location in the drawing. Like, for example, if you look at this drawing, this and this, these two sides are corresponding. And the way you can tell is the way it's listed. It's all about how the shape is listed. So this is what you look at. It's how it's listed or written. I'll call it listed. Okay, usually it's in the given, it's somewhere in the problem. Notice AD and EH are in the same location in how it's written. So in other words, AB and EF are corresponding because it's listed like that. I'm looking at the first two letters. Then we have BC and FG is corresponding or in the same location because it's written like that in the problem. And then the last one, DC and HG are also corresponding. So I'm looking at the way it's listed. That's what you're going to have to look at. And then it just tells you all that. Now we got sides. These are sides, and there are 4 of them, yeah, with a little bar above it. And then we have angles. So the angles are also congruent, and they belong. Angle A corresponds to angle E because A and E are in the first location how it's written. Angle B and F are corresponding because they're in the second spot how it's written. C and G, third spot. D and H, fourth spot. So you're looking at this mainly, okay? Sometimes the shape makes sense and you can figure out which parts belong together. Let's read the definition. So this is important. I always want you to read these key concepts. Congruent polygons. A polygon is a many-sided closed figure. In this case, there are 4 sides. It's called a quadrilateral. Triangle is a polygon. Okay, the word poly means many, gons is sides. Have congruent corresponding parts, their matching sides and angles. So we always talk about sides and angles. You got to keep that separate. How do you list sides? How do you list angles? When you name congruent polygons, you must list corresponding vertices, which are your corners or angles. Notice the corners are the angles. Those are called vertices. This is plural for vertex. Singular, it's vertex. And you must list them in the same order. Yeah. Okay, so this should make sense, I hope. I'm going to the next page. We're on page 122, and we're going to do the second problem. Skip the first 2. You're going right here in the middle. This is a roof, a truss. It's called a truss. So if you build a house, you're going to a truss yard and they'll sell you those prefab trusses, and that's how you build your roof. Notice we got some triangles going on here, several, the big one and then the smaller ones. This is not very focused. The attic frame truss provides open space in the center for storage right here. In this truss, look at how it's listed. This is what I'm talking about. It always lists it. This says triangle EFG, so I'm right away looking for it. EFG, so this little triangle is congruent to triangle HIJ. So I'm looking at the diagram, make sense of it. List the congruent corresponding parts. So you can go here and say, well, obviously this goes together, this goes together, and this, but you should also really look at this because this is how they list it. E and H are 2 equal angles. F and I and G and J. But now we got to list 6 things. We got to list, make sure you list. I'm going to write that down because students forget. Since it's a triangle, you got 3 sides plus 3 angles. You need 6 things altogether. So start with the sides. EF, I'm just going by what's this saying. EF is congruent to HI. And the bar means it's a side. FG, congruent to ij, and eg congruent eg to hj. So these are the sides I just listed. Now comes the angles. We got to have 3, 2. Angle symbol E congruent to angle H. Angle F congruent to the middle one, angle I. And the last one, angle G, is congruent to angle J. Now these are all the corresponding parts. So if the problem lists the shape in this fashion, I always go to the way they list it. If that's not there, you need to go to the picture and decide which ones are the same. That's harder because sometimes they all look equal. So this is really the best part to have in the problem, okay? All right, so then I'm going to show you problem 2 on the bottom. Suppose that triangle WYS is congruent to triangle MKV. So in this case, I'm going to draw it out because I'm getting confused with all these numbers and symbols. So sometimes a diagram really helps. So I'll call my first triangle WYS. Those are the corners. And then the second one is, it tells me they're congruent. This is the part that's already good. I know these two are congruent. MKV. I have to put them in the same spot. And I got measure angle W is 62, so I'm putting that in here. And measure angle Y is 35. And because they're congruent, I know these are the same over here. The question is, what is measure angle V? This is what I'm looking for. So it's this triangle right here only served the purpose of telling me these two angles, and I can transfer them to this. The question is, what is measure angle V? So remember last lesson, the triangle angle sum theorem says the sum is always 180 degrees. So you're going to add these two. 7, 9, and then subtract the sum from 180 will give you the third angle, 83 degrees. I'll just say, okay. And it says explain, so here's my answer. I used the fact that the sum of all angles in a triangle equals 180 degrees. So that's called the triangle angle sum theorem. And my answer is right here. How do you know which sides and angles correspond? I look at the way it's listed. Okay, that's how I know which parts go together. Next page, we are on page 123 on top. We're going to look at these two pyramids. Notice how it's listed. These are actually not triangles. Notice we got four angles. So it's really talking about this. This is called a trapezoid, in case you're interested. So I have to look A, B, C, D. A, B, C, D is this shape. Congruent. It's telling me they're congruent. This is an important fact. I now know that everything matches. All the angles and all the sides are the same. So it's asking for AD. This is a segment or a side. AD, and I go over here. These two match. This is 335 feet. Therefore, this has to be 335 feet. Because AD goes with EH, which makes sense in the picture. I mean, it looks like that. And then it says measure angle DCB. This is something you need to learn, how to name an angle if you're using the two sides. So the D is, where's angle D? There we go. D, I'm going to make it green. D, and then you follow the path to C and you end up at B. DCB. That tells you it's this angle you're looking for. So that's the same one as this one. So it's 128 degrees as well. Okay, so that's this top. Now let's look at down here, problem 3, finding congruent triangles. Is triangle ABD congruent to triangle CBD? Justify your answer. So if I look at ABD, which is this left side, this one, and this one, if I flip this one over, it looks like it would cover it perfectly. Especially because these two sides are the same length. Do you notice these are called dashes, and you can see that AD is congruent to DC. So if those two are the same length and I flip it over, yes. You can flip one over onto the other. And moreover, side AD is congruent to DC because of those dashes. Those are the markings you got to look for when you do your math, okay? Look at this one here. We have angles and side markings. This is an angle congruent to this angle. These two angles are congruent because now you got two bows. Two dashes means these two sides are congruent. They're asking if this triangle is congruent to that one. Again, I can flip it over. All the sides and the angles here are equal, definitely are congruent. Oh, I just lost my tool thingy. Why, I do not know. Okay, so I'm going to say yes. Oh, what? Wait a moment. Hang on. See if that works again. Huh, weird. Change color. Because I can flip over onto the other. I'm just going to shortcut it. I'm hoping you understand what I'm talking about, flipping it over. And we are also certain that side length and angles match. Not all of them. We still have this angle to deal with and this one, but we got two angles and two sides. Now, when I say two angles, I mean in each triangle. We got two angle pairs, yeah? In all actuality, you're seeing four angles, but we're talking about each triangle has two angles and two sides that match up to the other one. Go to the next page. We're on page 124 on top. Now these two, we're still looking at the same questions. Are they the same? No, because you notice the sides are not the same. Not congruent. You can shorten it with that symbol. Sides are not equal. Okay, There's this symbol right there. Okay. Recall over here in the middle, the sum of the measures of the angles in a triangle is always 180. The sum of all three angles, when you add them up, no matter what the triangle shape is, it's always going to add up to 180. This is super important. And I will hope when we do our assignments that you're not going to be stumped with that, because you need to make yourself notes that are easy to read. So highlight and reread your notes, check them out, 10 minutes maybe, sit down and read them, okay? And then it's easy to recall these. A lot of us just write them and forget them. Nope. Okay, third angle's theorem. It tells you that if you know that two angles in two triangles are congruent, the third angle is congruent by default because they're all adding up to 180. So all we need in two triangles to show the two triangles are congruent, we only need two angles, not all three, because the third one, by the third angle's theorem, will always be equal, right? If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent by default because their sum is always 180. Okay, so that's what this means. So really we only need two angles to show two angles congruent to show that two triangles are congruent. Okay, so then we're skipping this proof on the bottom, but we are doing a proof up here. We're now on page 125. We're going to look at this. Okay, so remember when we prove, we look at the given. The given is the information you have to work with, and that you have no doubt is true. What you're coming up with yourself to add to the proof, that might not be true. You have to be really sure it's true. So I'm looking at my two triangles. Notice I got this one and this one, and we're supposed to prove they're congruent. The given says angle A is congruent to angle D, and that's already there. It's already marked up. You need to do that yourself if it wouldn't be there. And then it also says that AE is congruent to DC. It's already marked up. That's a side with a little dash. EB and CB, EB, two dashes. And BA, this side congruent to that side, three dashes. What we're looking at is we're looking for two angles. We want to show that two angles, that's how we can prove it. Plan, we need two angles because we just learned about our two angle theorem. But we only got one in the picture. So we have to find another one. We only got one so far. So I need two angles because it says if I know two angles are congruent, so I'm going to come up with this one here. These two angles are congruent by their vertical angles. So when the lines cross, those two angles always congruent. So I'm going to write that up and now I show. Okay, so I'm going to say this is called a paragraph proof. I'm just writing about it. We have one set of angle pairs. Congruent in the given, right? It was in the given right here, but we need two. So I'm coming up with another angle. I cannot call it angle B because it would be ambiguous. It would not show clearly which one angle B I'm talking about. So I'm going to call it angle A, B, E is congruent. So A, B, E is this angle here. is congruent. Try to name this one yourself, CBD, because they are vertical angles. Which are congruent. Vertical angles are always congruent. So now I have two angles. Congruent. And therefore, this is therefore triangle AEB. All I need is two angles. Remember that last theorem? The third one is automatically congruent to DCB. I'm just copying what I'm proving from up here. By, what was that theorem called? I'm looking for the name. Oh yeah, third Angle's theorem. That's a paragraph proof. So let me reread that. We have one set of angle pairs congruent, which are given, but we need two. So angle ABE congruent to angle CBD because they are vertical angles, which are always congruent. A lot of words, huh? Now I have two angles congruent, and therefore the two triangles are congruent by the third Angle's theorem. Perfect. Okay, next page. We are on page, wait, is this it? Oh yeah, so we're starting on our homework. So we're on page 126. You're going to do, make sure you write these down, circle them. A lot of times I check your work and you're telling me, well, you didn't give this one, but yeah, all I have to do is look. So complete the following statements. This is called corresponding parts, checking if you understand corresponding parts. Remember the ones that are in the same location. When you do your homework, go down the exercises in order. They will come up. Given triangle QXR is congruent to triangle NYC, therefore QX, this part has to be congruent to what in the second one? You fill in the blank. Angle Y, this angle has to be the same as what angle in the first one? You fill that in. So that's how these are. Notice these two are triangles. This is a four-sided figure. These two are four-sided because we got four corners, four letters. Okay, in number 11, sometimes it helps to draw it out. And if you can't figure it out from what they're saying, it's mostly about checking for corresponding parts if you understand how to find them. On the bottom, this is a question that you're not going to get an answer from me because this is all up to you. When do you think you might need to know that things are congruent in your everyday life? I do not know what you're going to say. That's up to you. It's one of those questions that you can think about something totally that is concerning for you. Number 15 on page 127, you got to figure out which is the correct answer. Okay. By the way, these are also called congruency statements. This is called a congruency statement. I should have said that earlier because it comes up a lot. So I'm going to go back to one of the earlier ones. And I'll write that above here. Congruency statement. Oops. Oh. Okay. Now, where were we? So we're on this page. No problem. We got one more question, and that one is the hardest one on page 128. So I expect you to really try that and ask me if you don't get it. It's the 21 on top here. Think about a plan. Let's see who can stretch their knowledge. Triangle ABC. I always look at the diagram, make sense of it, is congruent to DBE. These two are congruent. Find the value of X. Wow, that always tells me we got to somehow write an equation at the end and solve it. Anytime you have a variable involved, an equation comes up. What does it mean for two triangles to be congruent? You can answer that. Which angle measures do you already know? You can answer that. How can you find the missing angle measure in a triangle? Most likely, if you know 2, you can find the third one by subtracting the sum from 180. Those are the clues I'm giving you. I also see a vertical angle in this picture. So good luck with this. I'll see you later.